State the transformations in the correct order. So you start inside. The order it goes in is reflections, stretches and shrinks, shifts. So starting inside, we have a negative that reflects over what? Close. Y-axis. Good. Bless you. And everything inside is kind of backwards. So the +5 is left 5. Then we go outside. There is no reflection outside. Next is stretches or shrinks. So that 3 vertical stretch by 3. The ones outside make sense. Everything outside just makes sense. 3 stretch by 3. And then the inside is the one that's backwards. And then the -7 is down 7. Cool. Create a table of values for this problem. What I always suggest for everyone to do first is make the table of these points. And it is these 5 points that I'm highlighting for you here. And I'm just going to list them out. I'm going to go left to right for the sake of us, staying organized here. So we've got -2, 0, 0, 2. But what else? So I'm not just sitting here talking at you. What else have we got? 2, 0, good. 4, -2, 5, 0. Do you see how I put a lot of zeros in there? Did that on purpose to help you out because 0 is an easy number to deal with. Okay, so now we're going to make a table for the shifted values. X is inside, Y is outside. You guys are a class that likes labeling things. Let's go ahead and label that. X is the changes inside, Y is the ones outside. Did somebody back there say X lies? Is that the one? I like that. No one's ever said that. X lies. It's backwards. So do you see that 1/3? Nope, it's going to be a 3. And do you see that -1? Nope, it's going to be +1. X lies. I like that. I'm going to steal that. So do you see how it was a 1/3? I made it a 3. See how it was a -1? I made it a +1. Okay. Now the outside makes sense. And all I put on the outside was a negative. Do you see that there? So it's just going to be -y or opposite y. Basically, you're just going to negate all of the y values. Actually, let's do that first because that'll be a whole lot easier. You're just going to do opposite. And I made a bunch of them 0, so they're not even going to change. So it's going to go 0, -2, 0, +2, 0. So basically, you're just going to take these x numbers and plug them in right here. So 3 times -2, that would be -6 plus 1 is -5. 0 plus 1 is 1. What would 2 give you? 7. Yeah, 6 plus 1 is 7. This would be what, 13? And then 16. Good job. Cool. That's all you got to do. All right. Write an equation of a line that goes through these points. We want point slope and slope intercept. So both of them. First thing you need is a slope. Do you remember how to find a slope from back in algebra 1? Yeah, y2 minus y1 over, no, you knew. Oh. So your y values, 8 minus 7. And then on the bottom, careful because these are negative. You'll have -5. Now it would be minus -1, which would be +1. Okay, so this comes out to, what is that, -1/4? In case no one ever sat you down in a chair and explained this to you, when a fraction is negative, you can put the negative on the top, on the bottom, or just out front. It doesn't make a difference where you put that negative. Okay, now when you do point slope, I use the first point for literally no other reason than it's the first one. You have to pick one, just pick the first one. This is how I teach it in algebra 1 as well. And these are your ingredients. You just put them into your recipe. That's how I teach it to my freshmen. Okay, these are your ingredients, put it into the recipe. It's y minus which one of those numbers? The -1/4, the -1, or the 7? Hint, it's the y one. 7, good job. Equals, do you remember what comes next in your recipe? It's either the -1/4 or the -1. Yeah, it's your slope that comes next. This is point slope. Parentheses, and then it's x minus -1. Now that'll be x plus 1. That is point slope. The formula, yeah. The reason I kind of don't write this if it's going to bother you, okay? Because the ones tend to throw people off sometimes, okay? But if that helps you, this is your slope. This is your x value, and this is your y value. If that helps you, if that does not help you, don't write it. If that just confuses you, don't write it down, okay? Yes. That's point slope. Congratulations, you're a normal person. I'm going over it. Yeah, so fair, okay? But I'm going over it now, so you're going to be okay. All right, now there's two steps to turn it into good old y equals mx plus b. You distribute, and then you get the y by itself. So we're going to distribute the negative 1/4. That's going to be negative 1/4 x minus 1/4. Now, do not write plus 7 plus 7. In essence, we do want to add the 7 over so that we have y by itself, but you need a common denominator. So here's the $1,000,000 question. How many fourths is a whole 7? 28. Very good. So we're going to add 28 fourths, which is the same thing as 7. You're writing plus 7 plus 7. You're just writing it in a way that it's going to work out for you. So your final answer is y equals negative 1/4 x. And then if you put these together, 27 fourths. All right, onward. What is your parent function for this one? All right, absolute value. We want to see how it shifted from the center. So from 0, 0, how did it move to get to this new center? Left 4, up 2. Good job. So left 4, up 2. It also got stretched a little bit. Do you see how it's like narrower? It got stretched by how much? Well, it's going to have to be a whole number. And it is 3. Do you see how this point is 3 above that one? So vertical stretch by 3. And then you take all of that. This is, again, like your ingredients and you're putting it into the recipe. And you're going to write an equation that puts all that together. So it'll be f of x equals what? 3. Absolute value, which is acting like a parenthesis sort of there. What is going to go inside of it? Why is it plus 4? Because it's x lies. I like that. All right, and then plus 2. Beautiful. X lies. Y tells the truth. No, easy, difficult is always an opinion thing. All right, even or odd. Here's what you do. You plug in negative x. If it comes out the exact same, it's even. Exact opposite is odd. That's very convenient as far as how words work. Odd, opposite. If it's a mixture of the two, then it's neither. All right. So everywhere there's an x, you're going to put a negative x. And here's the thing. People try to force this to turn out a certain way. You're just seeing what happens. It's a test. You're trying to see what goes on. Now, negative x cubed. You don't have to write this if it's going to confuse you, but this is what that means. It is negative. Why? There's an odd number of them. So it's negative x cubed, and then negative 4 times negative x will be plus 4x. And then you just compare. The first term, do you see how that's the opposite of what we started with? And then the second term is also opposite, so we're going to say odd. Again, exact same would be even, and if it's like a mixture, then it's neither. So the negative times negative is negative, but x times x times x is still x to the third. You still have 3 of them. The 3 didn't go away, so it's still there. Yeah, so like, for example, if you had this, that would be positive or negative? Positive, but it would still be to the 4th. Like, you still have 4 of them. The number doesn't go away. Okay. All right, x and y intercepts. X is going to be something 0, Y is going to be 0 something. I would do the Y one first. I think it's a whole lot easier to plug in 0. Ready? Here you go. 0 minus 1. -1. But then we're going to make it -1, so 1, which is good because square root of 1 is 1. -4 or -5 is -4. Sorry, I said the answer there. Now to get the X one, you have to set the whole thing equal to 0 and actually like do work. Womp womp. All right. So what would you do to solve? Did you say the same thing as me? Twinsies. All right. So what do you do first? Yeah, +5. It's not hard. You just have to actually work it out. All right. Then square. So you would have 25. And then can you watch me do this? This is the easiest way to get rid of a negative. Are you ready? Are you looking? Because if you look away, you're going to miss this. Scribble this out and just put it on the other side. Just dividing over a negative. That's the easiest way to deal with that. And then the last step is add 1. That's going to give you -24 is your answer. That wasn't so bad. Piecewise. All you have to do is make a decision. I get that that can be hard. Does -1 live in this first part or the second part? Do you see how -1 is smaller than 1? You're going to plug -1 into this, and that's your answer. You just choose which one you're plugging into. Say it was f of 7. Then you would use the second one. Do you get what I'm saying? Okay. -1 plus 1. Yeah, 0 squared. 0 plus 3 is 3. So you just have to decide which part you're plugging into is all that is. All right, discontinuities. There's 2 of them. Where's the first one? Yeah. Oh, yeah. -1 is smaller than 1. So we're going to use the first part. And I just plugged -1 into that and I got 3. It can't. A number is either smaller than 1 or bigger than 1. Number was... Yeah, so like say you were, I brought up 7. 7 is bigger than 1, so you would use this part. And you would plug 7 in, it would be -14 minus 1, so -15. How about if it was 1, everybody? Which one? Why would it be the top one? Because it has the equal to. So 1 plus 1 is 2, squared 4 plus 3, 7. That was a good question. If somebody asks a question, don't like start talking and ignore it. I want to answer it for everybody. All right, now there's 2 values where this is discontinuous. Where's one of them? -3 is correct. Removable or non-removable? Removable because it's just a hole. You just removed a point. You just yanked a point out. You removed a point. It is what it sounds like, all right? And then where's the other one? 3. Now that's an asymptote. You didn't simply remove a point. That's a more deep-seated issue. That's non-removable. If it's a hole, it's removable. Because you just removed a point. Now it's a hole. What's that? Well, removable, you removed a point, it's a hole. That's everything in math is what it sounds like or is named after the dude that came up with it, because mathematicians are not, you know what I'm saying? It's either like the whatever theorem that is that thing, or it's the Cole theorem and it's named after that person. All right, relative maximum. Let's call that 2.5. At x equals where? Are you guys with me here? All right, 2.5 at x equals -2. Good. Minimum is this point right here. Can we call that -4.5? All right, so -4.5 at x equals 3. All right, what else did we get asked for here? Increasing and decreasing. Increasing, I would go left to right. If this helps you, you guys are my class that likes to label. If this helps you, -infinity, +infinity, it's along your x-axis. So what is the graph doing first? Increase. So we increase from -infinity till -2. And then we decrease from -2 to 3. And then we increase again 3 to infinity. And you put the little union on there to indicate like, hey, my answer is not done yet. I still have more to say. All right, equation. These usually go okay, which impresses me because I think this is a difficult question, but it usually goes all right. I would decide where it splits first. At what X number does this break happen? At 1. So the first thing, we are going to have less than or equal to 1. Why did I put the equal to on that part? Close circle. And then the other part, greater than 1. I think it's easier if you decide that first. Now, the first one is super easy. Do you see how it's just a flat line at -2? It's literally just the number -2. Constant. There's not even a variable. That's all that there is to that. And then this one, it's a parabola. How did it shift from the center? Like, where's our new center? It went right to, up to, and it's flipped. Okay, so you need a negative. And it went right to, so that's X minus 2. And then it went up to, so plus 2. Cool. This is where I think I returned to you. Okay. So write this in vertex form. That means complete the square. We're going to take out 3, but only the first 2. Good. Good memory. All right. So that's going to leave you with x squared plus what? Because the common mistake is people write 24. 8. If you leave the 24 in there, your numbers are going to be too big. And you need to go, hey, I have done goofed. Like, the numbers are going to be too large. Now, the rule is you take 8, divide by 2. Nice. 8 divided by 2 is 4. Squared is 16. So you're going to put plus 16. That all usually goes well. Here's the difficult step. It's not a 16. It's a 3 times 16. 48. You need to turn a 48 back into a 43. So -5 is what you have to stick at the end. And that's the tough part. Again, 16 times 3 is 48. -5 is 43. And then you only have one more step. I taught you to write it as blank squared. What goes inside of there will either be x plus something or x minus something. X plus 4. Good job. Nice job, team. And that's the answer. All right, this says solve by factoring. Draw your parentheses. I'm writing with pen, so I hope we guess right on the first try, but if not, I'll white it out. 12 actually has a lot of choices. I think it's probably not 1 and 12, but your other choices are 2 and 6 or 4 and 3. What do you want to try? 4 and 3. Okay, let's see if we're right. At the end, 3 has to split 1 and 3. That's really the only options. I can already tell this is not going to work. Yeah, it's going to have to be 2 and 6. Bummer. You know what? That makes us normal people. Congratulations, we're all normal. All right, now where do I want the 3 and where do I want the 1? Because it is going to make a difference here. Yes, good. So now we check. The outsides give you 2x, 2 times 1. The insides give you 18. So you want plus 18 minus 2. All right. And then I always say it's a sad day if you stop there. You won't be able to forget because it's multiple choice. You have to set those equal to 0. So this one, you would minus the 3 and then divide by 2. So -3 over 2. And then this one, you would add the 1, divide by 6. I think I'm going to do one more and then I'll break that for our halfway because this. Actually, we'll do this whole page because these are all going to be pretty short. All right, do you have a positive or negative leading coefficient? What do you think? Good. Why is it negative? Because you're all brilliant. Right side goes down. Cool. Even because same direction. Even because these go the same way. Odd is opposite, which is just convenient for how we talk. Least possible degree. You take the number of turns and add 1. So 4. Now listen, if you just said the degree should be even, that needs to be an even number. Don't say it's even and then put 3. I'm always like, I read papers. I'm like, what are you doing? Everyone's so creative. Sometimes when I'm grading papers, everyone is so creative. All right, number of real zeros. Can you watch me point to this? You've got 1, 2, 3, 4, because this counts twice because it bounces. So 4. Now I made the whole thing non-calculator, so you won't need your calculator for this. I'm giving you the first 0. See how it's a -1/3? Like I literally just wrote it on the paper for you. So -1/3 goes in the little box. You're going to take all your coefficients, and what will the remainder be? It will be 0. If it's not 0, you have done goofed. It will be 0, I promise. It has to be. So if you bring down the 3, multiply, add, multiply, add, multiply, add. So -1/3 times 3. -1. Oh, that's actually going to make the next part of our job really easy, because what is this? Yeah, 0. Anything times 0 is 0. And 48 divided by -3 is -16. So ding, 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 came out to 0. Now, when you put the x's back, you start with 1 less because we divided out. So it'll be 3x squared. Yeah, no x's. I guess you could write plus 0x if you want to. Plus 48 equals 0. And then you just keep going. You have to go all the way to the bitter end. So what next? Yeah, minus 48. I'm going to in this step. So the reason why I didn't is because the middle one came out to 0. You totally can. Here, if that bothered you, I'll go back. You always equal it to 0. It'll always be 0. So if you divide by 3, that's going to give you this. It would have come out the same if you wanted to do it the other way. Personal preference, right? And then you subtract 16 plus or minus. Oh, why is it I? Because it's negative. Good job. Oh, wait, did I lose you? No, good. Well said. Nice job. That's why you're in groups. All right, and we'll do this one and then we'll do our break. It doesn't matter what order you do this in, but I always go right to left because you have to start with the right side. Do you see how it goes down? That means we need a negative. So I just go right to left to be consistent. So our first 0 is where? 2. That means the factor x minus 2. Good. And do you see how it wiggles there? So your power is 3. Good. And then the next one is at -1. So that's going to be plus 1. It goes straight through, so the power is 1. So you just don't put anything. And then the last one is at -4. So x plus 4. Good. Why is it power of 2? Bounces. Beautiful. So we're going to write our polynomial equation. If your 0 is -2, that means the factor is x plus 2, and then multiplicity of 3. This was the little triangle thing, which you can write out the triangle if you want. But for the sake of time, I'm going to just review the coefficients for you. When it was a power of 3, it was 1, 3, 3, 1. Does that ring some bells? Okay. And then you start with x to the 3rd, and it's going to count down. So 3, 2, 1, 0. I write the zeros even though I'm going to scribble them out because it's a pattern thing. And then you're going to do 2, but it goes the other way. So 0, 1, 2, 3. And then just stick some plus signs in between them all, and we're going to just reduce it. Simplify it. So I'm going to scribble out the ones that are to the 0 power. Those are gone. Again, I write them though because it's part of the pattern. But let's just write it out. We're going to have x to the 3rd plus what would this give us? Yep, 6x squared plus, make sure you do your exponent first. So good, 2 squared is 4 times 3 is 12x. And then 2 cubed is 8. Thank you for not saying 6. I appreciate you. All right, we're going to go ahead and factor that next one. So we're going to draw our parentheses. It's going to split x and x. And then 3 would split 3 and 1 plus 3 minus 1. And then same thing on the denominator, x and x. That one will split, yep, 1 and 7, 7 and 1, whatever order you want to write, it doesn't matter. And then what symbols? Minus 1 plus 7. Cool. Now I'm not asking you for everything. I'm just asking for like a few things. Domain. Who are your troublemakers that are getting kicked out? 1 and -7. So you have to leave out the -7 first because like it has to go in order. All right, vertical asymptote. It's either the -7 or the 1. It's one or the other of those. Which one is the vertical asymptote? Yeah, -7. Because 1 would be what? The whole. I didn't ask you for that, but it would be at 1. And then your x and y intercepts. I always do y-intercept first because I just think it's easier. You just plug in 0. Essentially, you can just cover up the x's because if they're 0, they're gone. So what are you left with? Yeah, 3/7. And don't be surprised if you get a fraction. The problem is a fraction. So like your answer could be a fraction. That's fine. Right. X-intercept is something 0. If you set this whole thing equal to 0, you multiply over the x plus 7, but what happens it's 0. So you end up with this -3. Good job. As we go forward, because I put it in chronological order, we're getting closer and closer to the more recent stuff. So like this was last unit. All right, same thing for this one. We're going to factor and then state all of the things that I asked you for. So this one has a 3 out front. So 3x squared, that's going to be 3x and x. 2 is going to be 1 and 2. I think we need a -6 and then plus 1. So -6 plus 1 gives you -5 in the middle. And then we're going to split the denominator. That's a little bit of an easier one. How would 8 split? 2 and 4. And plus 4 minus 2. As a heads up, I'm going to try and write in this section for this problem, just because for the next one, I'm going to need some space above this problem. So just as a heads up, I'm going to try and write over here. So the whole, I did ask you for the whole this time. That comes from what cancels out. So the whole is going to be 2 something. And how do you get the something? Yep, plug 2 back in. So let's see, if you plug 2 back in, that would be 7/6. Again, don't be surprised if it's a fraction. The problem is a fraction. Horizontal asymptote. This one's a little bit tricky. You have to compare your powers. Look where I'm pointing. Have your attention. All right, do you see how that's squared and that's squared? What does that mean you use? Coefficients, good, which is 3/1, which is 3. Now, I did this on purpose. Do you see how I asked you horizontal asymptote and then the next thing is end behavior? I did this on your test too, because those are going to be the same answer. So limit x goes to -infinity of the function is 3. Limit x goes to +infinity of the function is 3. I did that on purpose because they're all the same answer. Trying to help you out. And then the range, and again, I did this on purpose too, because I'm not making you actually do a graph. Usually we would just sweep downwards to upwards and look at the graph, but you don't have to do that here. So I put it all together for you. The values for the range that you skip over are the whole and the horizontal asymptote. So that's why I put them all in the same problem. So you're going to skip over 7/6, and then, oh, whoops, and then you're going to skip over 3. 7/6 is really close to 6/6. So 7/6 would be like about what? Yeah, like 1, well, 1 and a 6, you know, like 1 and a little bit. Smaller than 3 was the point I was trying to make. 1 and a bit. All right, for this one, do you see how you have an x minus 4 and an x plus 3? If you factored this, guess what it's going to come out to? X minus 4x plus 3. So that's your common denominator that you're going to write 3 times and not give me a hard time about. If you don't write it, you can't see what happens. And my pep talk is always, anyone can write the same thing 3 times. You don't even have to understand what's going on to write the same thing 3 times. Because you'll see what cancels and then what's still there. So what cancels in the first one? Good. You're left with x times x plus 3. So distribute through there. X squared plus 3x. What cancels for the second one? X plus 3. You're going to distribute not a 2, but a negative 2. Be careful with the negative sign. So if you distribute a negative 2 into there, that'll be negative 2x plus 8. Good. Equals. Now, I didn't make you write factoring this out because I was trying to save you a little bit of writing, but the whole thing is going to cancel and you get 14. And all of a sudden, it's a whole lot better. All of a sudden, get really cold in here. Like, did you just feel it shut off? Oh my goodness. All right, like terms. So 3x minus 2x is just x. And if I can do this in the same step, I'm also going to evacuate. If you subtract over that 14, you get minus 6 equals 0. So that is going to split into what? Yeah, 2 and 3. Perfect. And so your answers are 2 and negative 3, but we're going to get rid of negative 3. Why? Troublemaker. From the original problem. If it makes a 0 denominator, you get rid of it. Okay. I'm not sure if you had a question. Oh. Negative 3 was going to cause a 0 denominator in the original problem. Your troublemakers were negative 3 and who else? 4. All right, here we're going to make our number lines. I'm going to have a number line for my x plus 4. And then this is going to split x and x. 18 would split into what? You can do 3 and 6 or 9 and 2. Good, it would be plus 9 minus 2. Nothing weird is going on, which is good. It'll be like that on your test too. Nothing weird will happen on the test. Thank you for explaining that to everyone. All right, so to put these in order, x plus 9 is going to change at negative 9. X plus 4 is going to change at negative 4. X minus 2 changes at 2. And since nothing weird happened, how can you fill them all in? Negative to turn positive. Good. Negative to turn positive. If you don't like that, you can pick a test number. I'm just trying to save you some work. I know this is usually everybody's jam, is like drawing these out. Usually goes really well. And then drawing your little balloon strings, and you're going to decide what the overall sign is for the whole thing. So negative, 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 negative. And then it's going to alternate, right? And actually, this is the step. I usually say this is everybody's jam up until this point. Like picking the part that's the answer for some reason, like falls apart. It comes back to this symbol. What does this mean? Less than 0. So we want the negative parts. So it's going to be negative infinity to where? Negative 9. No brackets. Union. Negative 4 to 2. Why aren't there any brackets? No equal to. Perfect. Last page. And this is the stuff that you just did. Done anything mind-blowing yet. I think you guys are going to be fine here. All right. Which function do you start with? F or G? F. Good. We're going to do f of negative 2. I'm just going to write right above it. Negative 2 cubed. Negative 8. Negative 2 times negative 2 times negative 2. Negative 8. -2 times -5 be plus 10. So is that 3? Okay, so like telephone game, we're going to pass the 3 along to G. So now we're doing G of 3, which is going to be a whole bunch easier. If you plug 3 into G, you get -3 minus 3, so -6. Yeah, it's not bad. All right, for this one, you're going to take x plus 1 and plug it in to the other function. So -3. Now, don't write x plus 1 squared. Just write it twice. And actually, I'll save you some writing. Let's just do that part first. If you don't want to write the rest of it, that's fine. So it'll be -3 times x squared plus 2x plus 1. 1 times 1 is 1. And now I'll go ahead and write the rest of it. So it'll be plus 2 x plus 1 minus 8. It's just a lot of algebra. It is tedious, but not difficult. So we're going to distribute a -3. I'm not going to read all that to you because it's just going to put you to sleep. You guys know how to multiply. And then distribute a 2. And then combine. So -3x squared plus, or not plus, minus 4x minus 9. Thank you. Brain shut off for a second. All right, we're almost there. 3 more. Domain. Who's your troublemaker for f of x? 3. Kick out 3. And then this one is you have to be this tall to ride the ride. So we want -4 and above. So does G have a restriction? Yes, that means keep it. Good. F also has a restriction. That's where you set up a problem. Hey, G of x, you better not what? You better not equal 3 or else. So we're going to set up a problem. G of x cannot equal 3. And this is, again, one of those things where if you sat there and pondered long enough, I bet you'd come up with it because you're all smart, right? But that's not that hard to solve either. First step is square it. And so x can't be what? 5. Good. So you want to do -4 to infinity, but also skip over 5. So it'll look like this. You got this. You got it. Wait, I missed something. So do you see how G has a restriction? You keep that, -4 to infinity. But F also has a restriction. So it's, hey, G of x, you take this square root of x plus 4 and you say, hey, you're not allowed to equal 3. And then you just work that out. So you just do the steps to solve it. So we got that x also can't be 5. So you're doing both of these at the same time. All right, we're going to scribble out f of x and put y. And then how do you do an inverse? Switch them. As a heads up, there will come a fork in the roads in this problem. And you will have to choose positive or negative. Will we choose positive or will we choose negative? Negative. A bunch of you missed that on the test, and all it is a negative sign. You see how there's a negative infinity there? Negative. Well, you were right. Go ahead. No, you look at this right here. It says negative infinity, so we need a negative. If there was a positive infinity, then we would choose positive. This is not brain surgery, and like almost everybody in both my classes missed that negative sign on the test. So if you missed it, congratulations, you're normal, but I'd like for that to not happen here. Negative. See that? Right there. Hey. Let me finish this up and then I'll get you your review. Thank you. All right, so what's our first step here? Multiply by 7. So 7x equals all of this. And then square root, and you're going to choose negative. You don't put plus and minus, you're just making a choice. And then what's your last step? Yeah, -6. Right, and then last one, difference quotient. What is the first step? The very last one. Plug in x plus h. Okay, good. Yes. Now, does anybody remember what x plus h squared is? Because I told you we do it so often. It's x squared, 2xh, h squared. Good. Minus 7x plus h plus 3. I try to get everybody to kind of make that leap because it's already a lot of writing and you do that so much. It's good to just remember it. All right. And then what's step 2? Yep. Minus the problem, like just restate that. If you forget that step, you're going to catch it because nothing will cancel. And then I'm not going to write this right here, but what is step 3? Divide by h. I'll bring it back at the end though, because I get that it's a lot of writing. This is tedious, but not difficult. You're going to distribute, combine like terms. It'll be 4x squared plus 8xh plus 4h squared. And I'm going to stop reading to you because that gets really annoying. Let's just all make sure we get the same thing in the end. You're just distributing and combining like terms, which a lot of stuff should go away. If you don't get things to cancel, you've done good. These are very user-friendly problems because stuff is going to match up. So what goes away here? 4x squareds are gone. 7x is gone. One more. 3's are gone. You have 3 terms left and they all have an h. So you're going to factor out an h. And that's where you have to bring that back. Because the final thing that happens is that they cancel. And then this is your final answer.